So, welcome back my channel. Any PS videos, please like, share, and subscribe the channel. Give a comment, and so give me a comment, give a like, subscribe, and share with your friends. Support me. Thank you. Then coming to the next topic, reversible and irreversible reactions. Reversible and irreversible reactions. The final topic of the lesson in chemical reactions and equations. So we discussed many chemical reactions in various types of chemical reactions, like chemical combination, chemical decomposition, chemical displacement, chemical double displacement, oxidation and reduction. So here oxidation and reduction is also example for displacement reactions. Is also example for displacement reactions. So let us discuss the last topic, reversible reactions and irreversible reactions. So reversible reaction. Those reactions in which products can be recombined to give back reactants. So as you know, the substances which are involved in a chemical reaction is called reactants. These reactants gives us a new substance. That new substance is called as products. So, two or more substances or only one substance, whatever, if the substance involved in a chemical reaction is called as a reactant, the reactant forms a product. If the products combine together and gives the reactant back, that reactions are called as reversible reactions. Those reactions in which products can be recombined, to give back reactants is called as reversible reactions. So, for example, if we burn the candle, is example for reversible reaction or irreversible reaction? Reversible reaction, because when we burn the candle, the solid wax, when we melt it, it turns liquid wax. When we cool down, what will happen again? Wax become solid. So, reversible reaction. Similar, observe here, iron, red hot. When we heat the iron red hot, when it is reacts with steam, the react with steam. When iron react with steam, it gives iron oxide as well the hydrogen oxide, So iron reacts are combined with steam, nothing but the water or vapor gives iron oxide and hydrogen. So here iron and the oxygen are both are the reactants. If they give two new substances, the new substances are iron oxide and hydrogen. These are the products. Observe this equation. Then coming to the second one, iron oxide plus hydrogen are the products here. These products recombine. These products recombine and gives us iron plus steam again. So reactants gives the products recombine and gives reactants. So such reaction is called as reversible reaction. So finally we write the equation as iron plus water, a stream of water, gives us iron oxide plus hydrogen. So reversible reaction is represented with a double arrow. Represented with double arrow. Double arrow. So this arrow represents the reaction of direction of the reactant, direction of the reaction, and this arrow represents reverse the reaction. Means the reaction get back. The reaction is reversed. So this is the actual direction of the reaction and this is the reverse direction of the reaction. So we can represent with double arrow. Double arrow. So then take one more example. Nitrogen combined with the hydrogen gives us ammonia. NH3 you can call as ammonia. Ammonia. It forms ammonia. Right? So ammonia begin to break down nitrogen and hydrogen by the reaction. It is a reverse reaction. So when we break down the ammonia, again it gives nitrogen and hydrogen. Nitrogen and hydrogen. So when nitrogen and hydrogen combine together and gives a new product, ammonia. Ammonia is dissociated. Ammonia is decomposed. Ammonia is breaking down. Again it forms nitrogen and hydrogen. So finally write the reaction. Nitrogen plus hydrogen gives rise ammonia. Then reverse is formed. So reactants forms the product. Product forms again the reactants. Such reactions are called reversible reactions. Such reactions are called reversible reactions. One more example here. So hydrogen plus iodine. Hydrogen plus iodine gives hydrogen iodide. Hydrogen iodide. Hydrogen iodide. It is also example for reversible reaction. Sulfur dioxide reacts with oxygen. Sulfur dioxide reacts with oxygen in the product. It gives us sulfur trioxide. Sulfur trioxide. Then sulfur trioxide again dissociates or divides or gives the product as gives the reactants sulfur dioxide and oxygen. Sulfur dioxide and oxygen. So such reactions. These all are the example for reversible reaction. In a reversible reaction, right? Keep in mind, in a reversible reaction, reactants gives the products, then products recombine and gives reactant cycle. Then coming to irreversible reaction, exactly opposite. Products cannot recombine. Products cannot recombine to give back reactants. To give back reactants. So example, sodium react with water gives sodium hydroxide, which is a base, and hydrogen. In class 8 you learned reaction with water. Reaction of metals with water. Reaction of metals with water. So if we as you know, potassium, sodium and potassium both are, sodium and potassium both are the soft metals which are able to cut with our knife. So we have taken some piece of sodium and we drop in water. It forms, it gives a reaction to produce a hissing sound, and hydrogen gas also liberate. So sodium react with water, gives sodium hydroxide and water. But when these two are combined, with the sodium hydroxide combined with hydrogen, it won't give back sodium and water. Won't. So irreversible reaction. Similarly, reaction of metals with acids. Reaction of metals with acid. When zinc react with sulfuric acid, gives sulfur, zinc sulfate and hydrogen. Zinc sulfate and hydrogen. So this is also example for the irreversible reaction. Irreversible reaction. So to take one more example, calcium carbonate. Calcium carbonate react with hydrochloric acid HCl. It gives us calcium chloride plus water and carbon dioxide. It is a solid. It is an aqueous solution. Hydrochloric acid, nothing but we know. Then calcium chloride is aqueous solution. It is a liquid and it is a gas. So in this one also, reactants gives the products. These products did not give back the reactants. So such reactions are called as irreversible reaction. So in a irreversible reaction, reactants cannot form. Reactants cannot form again if the products are combined. So in a reversible reaction, products are recombined and gives reactants. In irreversible reaction, products cannot recombine to give reactants. So this is about reversible reactions and irreversible reactions. So this is our chapter, chemical reactions and equations. So let us take a brief mind map of our chapter. What we are discussed. So chemical reactions and equations. We are divided into two parts. Mainly we have two parts. One is chemical reaction and types of chemical reactions. We are categorized into two. Chemical reactions are categorized into two. Right? So let us this chemical reaction. We discussed what is a chemical reaction. In that we discussed writing a chemical equation. How do we write a chemical equation for the chemical reaction? Then after we discussed balancing chemical equation. The steps: first to write the whole equation. The second step, use the correct formulas and symbols of the substances. Then count or notate what are the elements or the substances are involved in a reaction. Then LH side and RH side. So LH side nothing but the reactant side. Note down the name, the elements or the atoms involved in a chemical reaction. Then note down the number of atoms involved both sides. So LH side are how many, RH side are how many. Then if the equation is not balanced, then multiply with a suitable number. The number which is used to multiply is called as coefficient. So after coefficient, reduce the equation and reduce the coefficient as much as the smallest number to give the proper ratio. then balanced chemical equation, and we also discussed how do we make a chemical reaction or the chemical reaction, the chemical equation more informative. How do you write more informative? By representing their state. Their state nothing but solid, liquid or gas. If any precipitate is formed, the downward arrow. If any gas is liberated, upward arrow. If it is the reaction taking place in the presence of heat, energy, then also any change in color. And we discuss the characteristics of the chemical reaction. In that chemical reaction, we discuss if any gas is liberated, precipitate is formed, heat is produced or heat is absorbed, then any change in the color also represented. So this is about the chemical reaction. Then in types of chemical reaction, we discussed chemical combination, then chemical decomposition, in that three are there. So in the presence of heat, in the presence of light, in the presence of electricity, in the presence of heat, you can say that thermal decomposition, it is photochemical, and it is electrolytic. Then we discussed chemical displacement, and the fourth one chemical double displacement, and oxidation and reduction. Additionally, we discuss reversible and irreversible. Reactions. So chemical combination, for understanding chemical combination, simply see, let us take one simple example. A plus B gives rise to C. Two substances combined, it forms only one product. So, okay, for example, it is taken as ABM. Then decomposition of AB disassociate gives us two or more products. A plus B. Combination two or more gives only one new product, AB. In decomposition, only one product decompose into two or more substances, A plus B. Then AB plus C gives rise to AC plus B. So in a chemical compound, one element of the group of element displaces by other. AB is a compound and C is the another one. C displaces the B. Then double displacement, AB plus CD gives rise AC plus BD. By changing the ions, by changing their constituents ions, so reaction takes place, double displacement. Oxidation and reduction, A plus O, AO2 is the oxidation. Adding of oxygen or removal of hydrogen. So from this AO2, if we AO2 నుంచి మనం డిస్క్రైబ్ చేస్తాం అనుకోండి, ఫర్ ఎగ్జాంపుల్ AO2 plus B అనుకోండి, AO2 plus B, then AB plus O2. AB plus O2, right? So, sorry, plus BO, B1, just for example, oxygen adding here, so new product form oxidation. So oxygen removed here, reduction. So we discussed some important definitions. What are the oxidizing agent? What is the reducing agent? Right? Oxidizing agent and the substance which gives oxygen or the substance to remove the hydrogen. Reducing agent means which gives hydrogen to remove the oxygen. So don't be confused. And we will discuss reversible and irreversible reactions. So this is a brief overview about the chapter chemical reaction and equations. Chemical reactions and equations. So for exam point of view, the chapter is very important. So most important topic, balancing the chemical equation. Balance the chemical equation by following the steps. By trial and error method. We have to balance each atom or the element. So which is involved in a chemical reaction. Balancing chemical equation. So they give some examples. So they give some reactions. So sometimes just given in the form of OD equation. For example, sodium combined with chlorine gives us sodium chloride. Sodium chloride. This is OD equation. So balance the following chemical equation. So this is a OD equation. First we have to write the formula by using symbols and formulas, but in equation also. Then count the number of atoms both sides, reactant side and the product side. Alla istaru leda simply so they give equation H2 plus O2 gives rise to H2O. Similarly, equation is given and balance the equation. So this is balancing chemical equation is a very important one. Then one thing I forgot here in this type of chemical reaction, exothermic reactions and endothermic reactions. In any chemical reaction, if heat is liberated, exothermic. If any reaction involved by taking energy is called as endothermic reactions. So chemical decomposition, either heat, light, electricity are the example for endothermic reaction. So energy is required. So they are the example for endothermic reaction. Endothermic reaction, heat or the energy is required. Exothermic reaction, energy or heat is liberated. Then these all are the very important. So explain the following reactions by giving examples. Then chemical decomposition. So electrolysis of water, thermal decomposition. These all the types of chemical reactions are very important. So double displacement reaction, one of the significance is insoluble substance is formed. That insoluble substance is called as a precipitate. So during a chemical reaction, in these types of reactions, is there any change in the color of the substance? In a displacement reaction, copper sulfate is, so if we add a piece of iron to the copper sulfate solution, it gives iron sulfate and copper. So carbon sulfate solution is blue in color, whereas after adding the iron is turns into other change, light green color change out. So in this way, asking the examples, and some examples are given. Identify what type of chemical reaction is. Is it a chemical combination or a chemical decomposition or a chemical displacement, oxidation, reduction, nothing but water. And then one of the important thing is one more, some type of chemical reactions. Some type of chemical reactions are carried out by the catalyst. By the catalyst. So catalyst. Catalyst is a substance. Catalyst is a substance which is not involved in a chemical reaction, but change the rate of chemical reaction. Catalyst is a substance which is not involved in any chemical reaction. But what will happen? Change the rate of reaction. This is also one of the important. Sometimes the reactions conditions such as temperature, pressure, catalyst are required, indicate above the below. So catalyst, the substance which is does not involve in a chemical reaction, but change the rate of reaction. One example, if you take one example, hydrogenation of oil. In oil, nickel is used as a catalyst for converting vegetable oil into vanaspati. To convert the vegetable oil into vanaspati, this reaction taking place in the presence of nickel. So such substance here, nickel is a catalyst. So just now we discussed one reaction, where reversible reactions are irreversible reaction. Right. We discussed one reversible reaction. SO2 plus O2 gives rise to this reaction. Taking place is example for reversible reaction. In this reaction is carried out in the presence of a catalyst. Vanadium oxide. So at the temperature 450 degrees centigrade. At 450 degrees centigrade, in the presence of vanadium oxide, sulfur dioxide combine and form sulfur dioxide, and sulfur dioxide again form sulfur dioxide and oxygen. So this is happened in the presence of vanadium oxide. So converting vegetable oil into vanaspati is taking place in the presence of nickel. In the presence of nickel. Here nickel and the vanadium, they are not involved in a chemical reaction. They did not involve in a chemical reaction, but they change the rate of reaction, speed. The rate of change of the rate of reaction is changed. So sometimes while writing a chemical reaction, chemical equation for the reaction should represent the conditions. Should represent the conditions. So this is an example. AgCl. So this is overview of lesson. One more example, catalyst key. H2O2 gives rise to H2O plus oxygen. Here MnO2. Manganese dioxide. In the presence of manganese dioxide, hydrogen peroxide. It is called as hydrogen peroxide. Which is used to clean the wounds. Hydrogen peroxide dissociate and forms H2O and oxygen. This reaction taking place under the presence of MnO2. Manganese dioxide is a catalyst. It won't involve reaction. Either not involved in product side, reactant side, not involved in the product side also. So won't involve reaction, but change the rate of reaction. So doesn't involve. So MnO2 acts as a catalyst. Catalyst is a substance which doesn't involve in reaction. Then, so conditions. Here in this reaction we have to write V2O3, vanadium oxide. So 450 degrees Celsius. For in any chemical reaction, while writing the chemical equation, if the reaction taking place in a particular conditions like heat, pressure, temperature, catalyst, we should write on the arrow mark. So photosynthesis is the example. For example, CO2 plus water. In photosynthesis के sunlight. Chlorophyll. Sunlight required, chlorophyll also required. Then it gives C6, H2N, O6 plus oxygen. Right? Biological chemical equation 6, then 6. Photosynthesis taking place in the presence of sunlight and the chlorophyll. Sunlight and chlorophyll is particular condition. Here, vanadium oxide temperature is a particular condition. MnO2 is a catalyst which is also taking place in a particular condition. So, if any chemical reaction taking place under the certain conditions, such as temperature, pressure, catalyst, or any other presence of substance, so should be right, indicate above or below the arrow. In the equation. So this is about chemical reactions and equation. So please watch the videos regularly, listen the classes regularly, share to your friends, subscribe the channel, give a like and make a comment. So for betterment. So your cooperation, your encouragement is the very important. So I am explaining as for my benefit, and you also get some benefit during these classes. Even the holidays or after the school also you will get benefit. So this is about our chapter, the first chapter, class 10, physical science, chemical reactions and equations. Thank you so much. Signing off.